Find the equation of a line that comes close to the points listed in the table. Then use a graphing calculator to check that your line comes close to the points. Well, we have a table there with x and y values that we can place on our graph. Well, let's label our axis, x and y axis, first of all. Okay, and let's say it starts at 0 on the corner, lower left corner. Increments that we could probably use, well, the x-axis, we could definitely use increments of 1 for our x-axis. So increments of 1s, there we go. Y-axis, it goes from 5 all the way up to 18. It looks like we might have enough space to put increments of 1 as well for our y-axis. Depending on what size you build your graph on your paper, you may want to go with different increments. But for this case, I'll go with 1 since it seems like you'll have enough space. And let's try plotting the points. So plotting the first point, 1 and 18. Next point, 4 and 14. 5 and 12 is the next point. 7 and 8 is the next point. And 10 and 5 is the next point. And there we have a scattergram. So we just built a scattergram. Well, that implies it's just randomly located points based on our table for this case. Let's do a line of best fits. Line of best fits, basically a line that describes the data. So it's the line that comes in the middle of most of the points possible. You may have a different point of view, but in this case, the line of best fit seems to be somewhere around there. So it looks like something like that line would be the line of best fits. Yours might be slightly different, but it should be pretty close to what I have here. So in this case, let's remember that y equals mx plus b, our slope-intercept formula. I highly recommend you write this whenever you're working on your problems. At the top of the page, write it out. Y equals mx plus b. It's good to have it. And remember that the slope is the m, the y-intercept or the v-value is basically the v-value. But do remember the y-intercept is the full coordinate. So it must be in the form of 0, comma v. Okay, let's pick a couple points. It looks like 1, comma 18 is a good point to select. You don't necessarily have to select data points. You could locate a corner on that graph, particularly where it lands in a corner, I should say. But in this case, 1 and 18 is a good coordinate. And let's see, the third coordinate there should also be a good coordinate because it seems to be on that line. So 5 and 12 is the other coordinate. And let's remember our slope formula. M equals y2 minus y1 divided by x2 minus x1. But in this case, keep in mind you don't necessarily have to label them. That is just for reference, stating that you have two coordinates. In this case, we're going to state that we have the y on top of the x for each one of those values plugged in for our coordinate. So main and critical portion is our slope formula. It has a fraction sign with a negative on top, negative on the bottom. That's it. That's our slope formula. Now to fill it in, fill in the blanks. So 12. Let's select the 12 and the 5 first. The 12 is the y value, always has to go on the top. The x value has to go on the bottom. Same coordinate, agreed? Now to repeat it, but for the other coordinate, we need the 18 on top because it's the y value. And the 1 goes underneath because it's the x value. And now we simplify. 12 minus 18 will give us 6. And 5 minus 1 will give us 4. Okay. And let's take a look. And do remember that 5 minus 1 will give us positive 4. 12 minus 18 will give us, well, that'll be a negative 6, right? Well, it doesn't matter where you have the negative, whether it's on top, on the bottom, or in the middle, okay? I would highly recommend you put it just in the middle to make it easier to avoid confusion. And let's simplify this. Simplifying this by dividing by 2 because it's an even number on the 6 and 4 is also an even number, so it's a multiple of 2. You can say you're dividing by 2 or think of saying halves. Half of 6 is and half of 4 is, so once again, let's put the sign in the middle. Half of 6 is 3, half of 4 is 2, or 6 divided by 2 is 3, 4 divided by 2 is 2. It gives us the same results. But for some reason, thinking of halves makes it easier in some cases. Okay, So we have our slope so far, and it's simplified. So let's plug it into our equation. Y equals mx plus b. We now know the slope is negative 3/2. So we have negative 3/2 x plus b as our formula now so far. But we want to find the v value so that we can have the full equation. So let's use one of the coordinates from above. Okay, so using the 5 and the 12, once again, do remember we already have the slope. So we're just replacing the x and y values. Y value is 12, x value is 5. And now we simplify. Hey, but look at that. We have negative 3/2 times 5. 5 is not a fraction format. Do remember, you can always put a 1 underneath. Agreed? And this will make it into a fraction. So we have 5 whole numbers. So 5 over 1 in other words. And now it makes it easier, because now we can multiply. Notice that parentheses implies multiplication. So 3 times 5 gives us 15, and 2 times 1 gives us 2. But remember the negative. Okay, so let's multiply them together straight. Once again, now we have 3 times 5, 15, negative 15. 2 times 1 is 2, positive 2. And let's try to simplify this. Okay, 15 divided by 2 gives us, well, let's convert to a decimal. It's okay in this case. We have negative 7.5. When we divide 15 divided by 2, we get 7.5, and remember we had a negative originally. So let's solve for b by getting rid of the 7.5. It's a negative, so let's add 7.5 to both sides of the equal sign. 19.5 equals b. 12 plus 7.5 gives us 19.5, and negative 7.5 plus 7.5 cancels out, giving us the v value. So we have the y-intercept value, 19.5, and our slope, negative 3/2. So we have our full equation values, or to fill in the equation spaces. In this case, the m value and the v value. So y equals negative 3/2 x plus 19.5. This is our solution. Essentially, this is the equation that we were looking for. Well, it asks us to try to graph on our calculator. So let's try to graph on our calculator. So I have a reference at TI 83. So if I go ahead and go to turn it on button, go to y equals, and I just want to enter negative. Keep in mind it's a negative at the very bottom of your calculator. So you got to put a negative sign and not a subtraction sign. Otherwise it'll give you an error. So negative 3 divided by 2, and then your x button right next to your alpha button, x, plus 19.5. 19.5. Here we go. Now we can go to zoom, and I'll start with the zoom standard, option 6. And let's see what it looks like. Well, I can kind of see it, but it's kind of hard to tell. So we go to zoom, middle top button, and I'm going to try zoom out, option 3. So you can push 3 or go down to 3 and hit enter. But I'll push 3. Notice it does nothing. It's waiting for you to tell it where to zoom out. I'm just going to hit enter. It's going to hit zoom out on the center. So now that we've zoomed out, I want to zoom in into the area where my graph looks similar to what we just came up with. So zoom button again, and then we want to do zoom box. Hit enter on zoom box or select option 1. And I'm going to move the cursor by moving to the left side and moving down first. That way I can see where it's at. Well, there it is. I can roughly see my cursor there on my screen. So I'll hit enter once. And this allows me to say start here. When I push up and continue to push up, I can kind of build a line. And I'll go to the right. It allows me to see basically a box, and I want to select a box that looks similar to what I have on my sketch on the left side there. So roughly there, I'm going to hit enter and say that's my box size, that's where it's going to zoom in into. So hitting enter zooms into that area, and that gives us a rough view of what we're looking for. If I hit trace up at the top second left, or pardon me, second right, that gives us an option of hitting any or entering any x value. Let's say I enter the x value of 1, which is the first coordinate we selected. And if I hit enter, it gives me that my y value is 18. That's correct. That's the one we selected. We selected the other coordinate to be a 5. So if I put 5, that gives me the x value is 5. Hit enter, it gives me the y value is 12. That's correct. That's the other y value that we selected. So our coordinates are there. Let's go one step further and actually plot the dots in our calculator so we can visually see if it looks similar to that. So for that, we got to go to stats. But before I do that, I'll go to second, y equals, and I want to make sure my plot is set up. So second, y equals gives me this screen, and I want to hit enter. And I'm making sure here I can turn them on and off. I won't worry about that, but the type is what I'm worried about. I want it to be scattergrams, dots. That's the first selection, dots. My X list, I want it to be L1. My Y list, L2. And I have marks. I'll use squares since they show up the best. The dots kind of fade away. The plus signs, I kind of misconcept them with the cursor on my screen. So if you have color calculator, that's totally fine. You can select what color you want. But for now, I'm going to go to stats. Stats, since everything was set up correctly, we want to go to edit, hit enter. And on list 1, we're going to enter our list. If you had something before, let me enter something real quick. Let's say you had a list already. To be able to get rid of your list, go up to the top by pushing up to the top. There it is at the very top. It's highlighted. Hit clear. You can push down or enter and it'll get rid of it. Avoid hitting the delete button, okay? Always hit the clear button. Delete will get rid of your entire list label. So for now, we have our list labels cleared and we want to go to 1, hit 1, enter, 4, enter, 5, enter, 7, enter, and 10, and enter. Now I want to push to the right. That makes it go to the right L2. Remember, we're filling L1 and L2, just like our settings in the second y equals option. So L2, let's see, we're entering 18 and hit enter, 14 and hit enter. Of course, I'm typing with my keyboard, so do be aware of that. 12, hit enter, 8, hit enter, and 5. Hit enter. So you hit enter each time. And that should be able to see it on your graph. We go to y equals, so press the y equals button. And right now it won't show it. We gotta go up. So push up until you're at the plot option at the top. Now you want to hit enter once. By hitting enter, I'll push down and I'll notice that it turned it on. To turn it off again, I can always go up to the top and hit enter, and it will turn it off. You can do the same thing with the equals. Turn it on and off by hitting enter. But for now, I want to turn my plot on. So I'll go up to the top, plot 1, hit enter. Yep, missed it. There we go, plot 1 entered. And highlighted means it's on. So we'll go to the graph by pushing graph. And I should be able to see my dots. And there it is, my line of best fits. So it looks similar to what we have on the left side. So now we concur that, well, it's pretty close to what we calculated. To remember, your calculator can also calculate it for you. So second mode gives me quit. And I want to try to have my calculator do some calculations. If I go to stats, under stats, now I want to go to the right at the top where it says calculate. By pushing to the right, it'll give me calculate. And I want to select option 4, linear regression. So I can go down and hit enter on number 4 or push number 4, and it'll give me linear regression. TI-84s, you may get a few more options, but all you have to do is hit enter, enter, enter a few times until you get something like what I'm going to get. I only have to hit enter. TI-83s automatically select L1 and L2, but TI-84s should give you an L1 and L2. By hitting enter, enter, enter on a TI-84, you should get something similar to what I have. If you by chance get an R or R squared, don't worry about that. That's for statistical data. What we care about is the A value and the V value. A equals 1.5 and B equals 19.5. That's roughly what we got in this case. So it's just like saying y equals mx plus b, but they call it an A instead of a m. But it still works. Okay, so do remember that's the same equation as here, but I'll go to y equals, and under y2, I'm going to have the calculator enter that equation automatically by going into the bars underneath my arrow keypad. It says bars, and I want to do statistics. So option 5, statistics, and now I want to go to EQ at the top. So I got to go to the right, EQ, and it's reg EQ that I want, so I'll hit enter for option 1, and it automatically copies it. Note it's going to be the same equation because mine, I have it as an exact form, basic meaning fractions. And the one that I got from the calculator is just the decimal format, but it's equivalent in this case. It's actually exactly the same for this case. Sometimes you get something similar or very close to the same, but it still works. So if I hit graph, you just see another graph being built up at the top. Hit trace, it starts on plot 1. I don't want to be in the plots because that's the dots. I want to push up, and now it tells me on my y2. If pushing up or down will change the equation. Push up again on my y1. That allows me to move left or right on the graph that I desire. So that kind of gives us a reference, and now we can see that we actually made this correctly because the coordinates that we had, by hitting trace once again, entering a 1, it gives me, whoop, wrong value, trace, I gotta push up to be on y1 or y2. Let's go to y1 in this case. Hit 1, and it should give me 18 when I hit enter. Yep, gives me 18, that's the coordinate we used. And now if we select 5, I'm still in the option of trace. Hitting 5 and then enter should give me a 12. Yep, it does.